Okay, so now we work predominantly with the equation for a parabola in the format x squared equals 4ay. So this has to become as familiar to you as y equals mx plus b for a straight line, or x squared plus y squared equals r squared for a circle. This x squared equals 4ay. We know it's still a parabola, it's still doing the right things in terms of a single power for y and our x squared. And that's how we previously recognised a parabola, that our highest power of our x would be 2. Well, we still have that. Now, the bonus is that we can get the equation format much more quickly. But I guess it is, it does depend on the information that's given. So the information that's usually given we'll refer to as the focus and the directrix. And in this case, x squared equals 4ay will always be the general form for a parabola given. The vertex is at 0, 0. The focus is at 0a, and the directrix is at y equals minus a. What you're going to see in this table are some variations, but first off, we're just going to restate that. The parabola x squared equals 4ay is what we call concave up. So it's like what we would have previously said as a positive U shape. The focal length will always be a. Now, the focal length is not necessarily the number in front of the y, the coefficient of y, because that whole coefficient, as you saw back here, the coefficient is 8, but the focal length was not 8. The focal length was 2. Because what that coefficient, if it's written in this format here, if it's written in this format, the 4 has already been incorporated into that value. So whatever that number there is, you need to divide that by 4 in order just to get the focal length. Remember me at some stage saying 4 stays 4, never changes, however it might not look like 4. Well, I guess that's a good example there. It doesn't look like 4, but the 4 is fixed within that value 8. The focus is at 0a. The directrix would have equation y equals minus a, and the vertex is 0, 0. So if I'm going to let this here be S, my focus at 0a, then I went 3 units up. This is minus a, this would be my directrix, and we usually just use lowercase letter d for the directrix, and then I'll attempt to draw in a parabola. And like I said, I rarely get it looking geometrically correct, because what should happen is, and I'll just try and dot this, that distance was meant to be that distance. There's no way that's correct. But yeah, the distance from any point on your parabola to your focus is meant to be the same as the distance to the directrix. So that's clearly not the right parabola, for that is the focus and that is the directrix. That's all it means. That is not the correct parabola. But I'm not claiming to have drawn this to scale or accurately. I'm just trying to put the features on. With the second situation, what happens when you get a negative here? Well, the negative just turns your parabola upside down. So that's not too bad, but think about it. The focus now has moved to in here. It's upside down parabola, so it's going to go like this. Oh, I've drawn that with the wrong colour. It doesn't matter. You'll be fine, I'm sure. Now, this is the focus. The focus in this would be 0 minus a. And that's hence why how the a appears up there, because we've got a negative number. The directrix would be up here at a. That's your line D, the directrix, and your vertex again is 0, 0. So it's concave down, still has focal length A. The focus is at 0 minus A now. The directrix has equation y equals A, and the vertex is at 0, 0. Okay, what about when we swap the x and the y now? I'm not sure whether you would have done very much work on this previously or not, but this is a sideways parabola. And yeah, if you haven't worked with it previously, I guess you'll have to be paying a whole lot more attention to these questions now, and in particular to this equation. What is it that's changed? Well, we don't have an x squared. In fact, we have a y squared and x to the power 1. So this is just something, you know, I often talk about. It's how good you are at paying attention to detail. This is a small detail that you cannot afford to not see, not register. You can't afford to ignore it. You can't, yeah, if you don't see this as a y squared and a x to the power 1, it's a parabola on its side, then you're going to find questions difficult. So, you know, do whatever you need to do. If you need to write that, y squared x to the power 1 is a parabola on its side. Write it down. Put it in a summary. Do whatever's needed so that you actually can make the connection to that automatically. So I'm sure you're pretty good with the single y to the power 1 and an x squared giving you a parabola. Like I've just said, and if you're not familiar with this, please spend the time on it now. Spend the time now. It will, you know, possibly be the difference between whether you're successful in the future with this concept or not. So it's worth spending the time on it. So the parabola y squared equals 4ax is on its side and facing to the right. To me, it's like a positive because it's all positive here, no negatives. And so we get a parabola that looks like that, which has got it's going off in the positive direction. The focal length is still A, and the focus, this time, the focus moves over here. So now we're at, well, it doesn't have to be 3 units away, I'll just make it 2. So the focus is now A naught or 2 naught, but I don't want to give a one case example like 2 naught. I'm giving a general example. And so if I call the point A, it covers any value of A. So that's the focus. We know that's inside the parabola, yeah? Focus is inside the parabola at A naught. Move across A and nowhere vertically. The directrix would have equation now. How do we write the equation of a vertical line? Well, I'm sure, hopefully, it's not a problem to you. You know that the equations of vertical lines are x is equal to, and in this case it will be minus a. The vertex is still at 0, 0. We're yet to see how to alter the equation when the vertex moves. So again, and I probably won't get this very right. I'll try and make it even more shallow. Somehow like that. But the important thing is to indicate it's a parabola on its side. When we've got the y squared again, x to the power 1, if we can get it, or it's given to us in the format y squared equals 4ax, but it's got a negative, we now know it's going to be still a parabola on its side, but facing towards the negative. And again, yeah, write these sorts of things down if that's going to help you to learn that now, because that's the purpose of this exercise, to learn this new go-to equations for a parabola and realize that parabolas can, I think I said to you back in the very introductory exercise, the directrix will either be a vertical, which we've just seen now, or a horizontal line. So it's left facing. The focal length is still a, and that's the nice thing about it. So that gives us the distance between the focus and the vertex. The focus in this case is at minus a naught. So we're down here. This becomes our focus, and this would be minus some value and naught for y. The directrix has equation x is plus a. So it's here. It's a vertical line, and the vertex is still, like I've been saying, is at naught, naught. Now, the real advantage of learning all of that is once you're familiar with the geometric description and its equation, you're able to find the equation without needing, how good is that? Without using the algebraic methods. So, I strongly encourage you to follow these steps, and number one is critical. It's so important. Draw the sketch. Then identify which general form. So from above, do you want a parabola going this way, this way, this way, or this way? And you will get that from your graph, knowing focus is inside, directrix is outside. Also, you need to calculate the value of a, because you don't keep a in your final equation. You need the value of a, and you'll get that from your diagram. Then write your equation. I think I better stop the video now and do these examples in another video.